Today we're going to look at if-then statements because this is the most simple and probably the first proof template that you'll learn if you're taking a discrete math course. Now, we're going to look at an example that's not mathematical to start off with, right? So I am claiming right here that if I eat good food, then I will be happy, right? And we want to know, when is this if-then statement going to be true? And that's why right down here, I've drawn a little truth table, right? That's what this is. This is a truth table, right? And we want to know when our statement, if A, then B, is true, right? So here's what we're going to look at. There's four different scenarios we're going to look at. We're going to look at what if A is true, right? If A is true and if B is true, then our claim, if A, then B, must also be true, right? And that makes sense. So we're saying, I ate good food, I am happy, so my claim, if I eat good food, then I will be happy, is true, right? Now let's make these lines a little bit longer. What if A is true, right? So what if we got A is true and B is false, right? So I'm saying, I ate good food, but I'm not happy. Well, then my claim is going to also be false because I'm claiming if I eat good food, I will be happy. However, we have a scenario in which I ate good food and I'm not happy. So my claim is not true. If A, then B is also false. Now, what if A is false and B is true, right? In this scenario, right, where our condition A is false, that is not enough to falsify our if A then B statement. So let me try to make sense of that, right? I'm saying I didn't eat good food, yet I'm happy. That's not enough to say that if I eat good food and then I will be happy is also false, right? Because I never even did that first condition, right? The statement, if I eat good food, then I will be happy, could still very well be true, right? We don't have enough evidence to prove that it's false. So we would say that if A, then B is still true, right? And what about this? If I eat good food is false, and B, I will be happy is false, right? Then what do we have here? I didn't eat good food and I'm not happy, right? Well, I can't go claiming that if I eat good food, then I will be happy is false, right? There's no evidence for that. I never ate the good food, right? And I'm not happy, but that still is not enough to say that our if-then statement will be false. So we say that this is true, right? And in these scenarios where our A condition, right, where our A condition is false, then we say our if A then B statement is vacuously true, right? So this is something we're going to need to remember because this truth table is going to come into play in later lessons. So now that we've got like this real life example out of the way, let's go look at how we can use our if-then template to prove something mathematical. Now we're going to look at something that we already proved in a video, but we didn't really do it in a formal if-then format, right? So we are proving if B divides A and C divides B, then C also divides A, right? So how are we going to do this? Well, we make our if claim at the top, right? And then we'll put our then claim at the bottom, right? And to get to the proof in the middle, we kind of want to unravel definitions in between our if and then statements, right? Now, what do I mean by unravel definitions? Well, we have some definitions about divides, right? We're claiming if B divides A and C divides B, why don't we unravel what that actually means, right? So if B divides A and C divides B, that means that A is equal to B times some random integer x, and we'll say B is equal to C times some integer y, right? Now, okay, I'm not really sure where to go from here. So how about we look at our then statement and unravel the definition right before it, right? We want to show that C divides A, so that means that we can say that A is equal to C times some integer x, right? So this is where we want to get to, right? How can we write, and I'll actually, hold on. I will use a different variable since we're already using x. We'll say A is equal to C times Z. And so we already have A written in terms of B, and we have B written in terms of C, but we want A to be written in terms of C. So how about, and we've already done this proof before, how about we substitute what we have for B into our equation right here, right? Why don't we say that A is equal to CY times X, right? And this is true because A equals BX and B is equal to CY, right? Now something we also know, right, is that when we multiply integers together, that their product is also going to be an integer, right? So why don't we look at this instead as like e is equal to c times the product of y and x, right? These parentheses don't change anything. They're kind of just a, well, they do change things. This is just a visual representation, right? So we're going to multiply y and x together, and they have a product, right? The product is an integer. We don't know what that integer is exactly, right? But we can substitute a dummy variable for it, right? It's an unknown, so let's put a variable in for it, right? And we'll say that yx is just equal to z. And here we go. We've reached our definition. A is equal to c times z. Then c must divide a, right? So this is how we can use our if-then template to prove some mathematical concept, right? We want to make our claim at the top, right? We want to put our conclusion at the bottom, right? And unravel definitions in the center so we get uh, some cohesive like pair of definitions that will make our if-then statement true, right? And what's important to know is when you're writing these if-then statements, I just did a super easy one, right? You might not always get them on the first try, and that's not a big deal, you know? If you've never proven something before, what are the odds that you're going to prove it on your first try? The important thing is that if you ever make that mistake, kind of like right here at the top where I unraveled my definition and I was like, I have no idea where to go from here. So I started from the bottom and I was like, okay, well, this is my definition of C divides A. How can I go from what I already have to here, right? When you don't know where you're going, it's fine to make a mistake, to just try something, make a mistake, and if it turns out to be a mistake, figure out how to get around that. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.